Over the past year, email viruses have been one of the largest sources of loss of productivity and expense in corporations worldwide. Hi, I'm Kay Williams. I'm a lead program manager in Outlook, and I'm here to talk with you today about virus security prevention features in the Outlook 98 2010 products. Depending on which source you look at, you get different projections about how much money has been lost over the past year. But here are two different sources who indicate, in one case, $1.6 trillion taken out of the economy due to downtime resulting from security breaches and virus attacks. And another estimate, $2.66 billion. It's clear that email viruses are something that corporations are looking for Microsoft to take a quick stand against. Today we'll talk about Outlook virus security, and after we complete the Outlook section, we'll also talk about virus security enhancements in Exchange. And also, we'll look forward to some of the virus security features planned in the upcoming Whistler product. Email viruses, a few background facts about email viruses. They typically spread as attachments. They leverage programmatic platforms to self-replicate by gathering email addresses from the address book or from mail messages that would be sitting in the inbox. And they silently send themselves off to the people who they've gathered email addresses for. It's clear that virus writers, in order to have the most impact, pick ubiquitous environments. And that, plus the combination of Outlook's rich programmatic access, makes Outlook a key target for virus writers. So how do we prevent viruses? In the long term, the prevention that we want for viruses is something that's baked into the operating system, that's platform-driven, which will provide ubiquitous and comprehensive coverage. Microsoft is doing some work toward that in a product called Whistler, and I'll talk about that later on. But in the near term, in talking with customers about viruses, their request to us is to provide something that is available to the existing customer base. And that base of customers is largely using Win9X and above on the operating system. And they're using a range of messaging servers. Outlook runs against Exchange, of course, and it also runs against Lotus Notes, against CCMail, and against Internet servers, POP, SMTP, and IMAP. And for all of all of Outlook's customers, they needed a near-term solution that was independent of the messaging server. Another focus for virus prevention in the near term is to attack the 90% case. It's clear that not all viruses can be prevented without support from the OS. But many of the current viruses, especially the ones that are looking for ubiquitous environments, take advantage of Outlook in a way that by blocking some of the major tools they use, we could prevent the majority of viruses that go on today. And another near-term requirement is to complement existing virus utilities, both on the server and virus utilities that might be running at the OS level. So the Outlook virus security updates are available now for Outlook 98 and Outlook 2000 SP1. The update can be downloaded from the www.officeupdate.com site. And we've taken the virus security enhancements that we've made, which I'll detail in a moment, and added them directly into the Outlook 10 product. So what are the changes that we've made to Outlook to address virus security? Our approach is to provide a high level of security by default. We block executable attachments. We guard against object model or programmatic access to email addresses and also for sending mail. Additionally, we've disabled scripting for HTML messages so that viruses that expose themselves using DHTML or JavaScript in web pages could be sent, but when they are opened in Outlook, Outlook turns off the scripting capability so that simply reading mail messages will never kick off the spread of viruses. Those are the set of virus security measures that we've provided by default. Each of those measures is fully administrable by organizations. So they're fully exposed to customization. And the customization is done on the messaging server. The reason that it's on the messaging server is that that's a place that we can trust, that messaging servers are secured, and there's not a way for a virus to masquerade as the user in order to change the default settings. In the Outlook 10 product, we'll also be allowing some customization by advanced users. I'll talk more about that later as well. Details about the virus security around executable attachments. In Outlook, with the security patch in Outlook 10, users are blocked from opening executable attachments, both manually and also programmatic access to executable attachments is blocked. When users attempt to send one of those type of attachments, they're warned on sending or closing items that the attachment may not be available to the person who receives it. There are 38 file types included in our default set of executable attachments. And examples of those file types are .exe, .vbs, and .reg. A full list of the attachment types blocked is available from the Office Update site in a white paper that describes the Outlook security update features. In order to share executable attachments, there are some alternatives that we recommend. So the simplest alternative is to place files in a shared location, such as a file share or a web server, and then send the reference to that file as a hyperlink. Another way to send executable type attachments through email is to compress them first using a utility such as WinZip. Other attachments, non-executable attachments, are not blocked. In fact, there's no change from the previous Outlook behavior for these attachment types. There are other attachment types such as .doc, .xls, the Word documents and Excel documents that can contain macros. And for virus security in those cases, we rely on the applications, Word or Excel, and on the macro security in those applications. It's interesting to note that, or it's important to note that in Office 10, macro security will be set to high, which means that no macros will run in any of the Office applications unless the macros are signed. And the user also will not be prompted and asked whether they would like to run the macro. This is a change from previous versions. In Outlook 2000, only Word had macro security set to high. So as I mentioned, some examples of attachment types where there's no change in behavior is .doc, .xls, PowerPoint, GIF, JPEG, etc. Here are some screenshots of attachment warnings. The one on the top is the warning that users will get when they attempt to send an executable type attachment. And this this message tells the user that they can go ahead and send it, but they need to be aware that the recipient on the other end may not be able to see it. On the bottom, the screenshot on the bottom is an image of for a message opened in Outlook that contains an executable type attachment. This is the tooltip that will appear to the users. Actually, it's in the info bar of Outlook. There'll be a message that says that Outlook blocked access to potentially unsafe attachments. Should an email message contain both an executable type attachment and a non-executable type attachment, the info bar will describe the attachments that have been blocked, and the unblocked attachments will appear as normal, either in the attachment well or within the body of the mail message. Another prevention against email virus macro spread is object model guards. These guards protect access to address book data and also to recipient data on items. For example, to recipient information in the to field or from field or CC field of a mail message, or in the organizer or recipient's field of calendar items. Object model guards also prevent against the programmatic sending of email. And in this case, they bring up a prompt that indicates to the user that there's some application is trying to send in the background. If a program doesn't send silently, but rather brings up a mail message and has the user press the send button to send the mail message, then there is no object model guard against that, which means that there won't be any visible prompt to the user. That case will function just as it has in the past. The object model guards that Outlook has provided apply to the most widespread programmability models, specifically to the Outlook object model and to Simple MAPI. The default setting prompts users for each new mail message sent, and it allows timed access for other properties and methods. Here are some screenshots of the prompts that appear when on programmatic access to these features. In the top left, this is an example of a dialog that would appear when a program is trying to access email address information. This is the dialog that allows timed access. The reason a particular scenario that is useful to allow timed access for is for syncing programs, for example, for a Palm Top device. And so let's take the example of a Palm device. So the earlier versions of the Palm Pocket Mirror product had a synchronization utility. Actually, the utility is called Pocket Mirror, that communicates to Outlook to synchronize contact information. When synchronizing contact information, if the contact contained the email address of the contact, then on synchronization between Outlook and Palm, a prompt would appear. If users were synchronizing many contacts all at once, this prompt could appear repeatedly, maybe 30 or 40 times. Well, in that case, then the user could have allowed timed access for, say, 1 minute or 5 minutes and avoided all of the repetitive prompts. Palm has come out with a new version of the Pocket Mirror product. I believe it's their 3.0 product, and that's available for download from there's a pointer to the download site from the Palm website. And also the Microsoft ActiveSync product, which is included with our Pocket PC products, has an updated version. Both of those have updated versions that avoid the prompts on synchronization. The lower warning is what appears when a program is trying to silently send email on the user's behalf. In addition to the object model guards and to the attachment blocking, there are some measures, some additional measures that we've taken in Outlook 10 and also in the virus security update. So one of those is to set for the other Office applications, for all of the Office applications, the macro security level is set to high. So as I mentioned, with Outlook 2000, by default, only Word was set to high. And on installing the virus security update for Outlook, the one that's available on the web, that installation program goes through and sets the other products, Excel, PowerPoint, to high as well. In addition, we've changed the email rendering in Outlook for HTML messages to use the settings of the restricted zone in Internet Explorer. Previously, we had used the default zone, which had lower security settings by default, and now we use restricted. And then we've also changed the settings of the restricted zone in IE so that so that in that zone, any program that is running in that zone, no script is executed, no JavaScript, no DHTML. And in Outlook 2000, even if a user or administrator had reset the restricted zone so that script was allowed, Outlook 2000 takes an extra step to disable script regardless of the zone setting. That covers the default behaviors for the virus security measures in Outlook. Those measures can be completely customized by administrators. The administrative customization requires an email server with a secure location for settings. Administrators can control both the corporate defaults, and they can also set specific security, security features for individual users or for groups of users. So specifically, if I wanted to change my corporate default, let's say, and maybe change the object model guard support, set it back down so that there are no prompts when macros are running, I can make one change to a form and place it in a public folder, and that will apply to everyone inside of my corporation. I could also, alternatively, I could identify specific individuals who should have their settings modified. I can control it at either level. The administrative customizations also support individual control of the safeguard, so of the specific functionality. I can modify attachments, but leave the default. I can change the default behavior for attachments, but leave the default behavior for object model guards and for other security features, basically object model guards. And then I have fine-grained customization capability for specific object model guards, so for accessing email addresses on contacts or email messages or calendar items, I can control those at a fine level. And I can also control exactly which file extensions to block. So I mentioned earlier that there are 39 extensions that we block by default. An administrator could specify that 10 of those are allowed to go through without blocking, and the remaining should stay blocked. Also for attachments, there are 3 levels of attachments. Level 1 is complete blocking. That's the behavior where the tooltip appears that says that the file cannot be accessed. And there's what we call level 2, which forces the file to be saved to disk. The user can double-click on an attachment, and a prompt will appear that says that that file is potentially dangerous, and then ask the user to save it to disk and then they can open it from the disk. And the reason for that extra step is so that virus products that run at the OS level, say a Norton antivirus, once it gets saved to disk, then those virus products can scan it and give the user additional information about the safety of the item that they're opening. An additional administrative control is support for identifying trusted COM add-ins. So in Outlook 10, and this applies only to Outlook 10, an administrator can specify a list of COM add-ins that are trusted within that organization. And any user who attempts to run any one of those add-ins from the list provided by the administrator will be able to run it without prompt. The mechanism for that is that when the administrator adds the add-in to the list, the form on the public folder creates a hash of that file, and then when the user runs it on the user side, the hash is compared. This is the way that we can provide trusted support for COM add-ins without requiring the add-ins to be signed. So whether the add-in is signed or not, as long as it's on the list provided by the administrator, it can run without prompt. Server supported. The Exchange server provides support for administrative controls. The Hewlett-Packard OpenMail server also fairly recently announced their support for, and they have available, they announced quite a while ago, and they have available as of recently support for administrator controls. And the Lotus Domino server has also committed support, but I don't believe that that's available yet. Drilling in on the Exchange administrative control, for Exchange, administrative controls are public folder based. Offline support is allowed via the OST in Outlook 98 and Outlook 2000 SP1, well, just all of Outlook 2000. It's also provided by either the OST or the local store in the Outlook 10 timeframe. The way that this works is Outlook automatically detects if the administrator has created a public folder to store the security settings. And if that public folder exists, Outlook automatically adds it as one of the folders that gets downloaded offline. So there's no user intervention required in order to make sure that that folder gets brought down. The administrator overrides are also available for users who have specified that their primary delivery is to a PST. This is new support in the Outlook 10 product, and it's also available for Outlook 2000 via QFE. Specifically, it was not available in the virus security update that is available for download from the internet. Another new feature that we've added in Outlook 10 is the ability, another customization feature that we've added in Outlook 10 is the ability for advanced users to have control over executable type attachments. Specifically, advanced users can specify which executable attachment types to unblock. The way that they would do this is by using a registry key. There's no UI implementation. It's available only through a registry key. And from that registry key, they can specify attachment types that would be moved from level 1 to level 2, where level 1 is blocked and level 2 is saved to disk. There is no customization, advanced user customization for object model guards. The object model guard customization would need to be done by an administrator. And the advanced user customization, the registry key that advanced users can set, can be overridden by administrators. So from the public folder settings, the administrator can indicate whether Outlook can look at the registry for individual users to see which attachment types they can access, or whether Outlook should not look at that registry key and should only abide the information that's in the public folder. So the time frame for this is Outlook 10. It's not available in Outlook 2000 nor in Outlook 98. And it's also not available in the beta 2 version. It will come out in the released version. A couple of notes about deployment. So the Outlook security features are deployed within Microsoft today. Outlook 2000 with security is broadly available from the product's released SharePoint. And the way that that has been done is that the administrative install that sits in that location has been, so we've created an updated administrative install that is a combination of SR1 plus the security patch. And that allows users to do a single install rather than a phased install where they do first SR1 and then they apply the security patch on top of that. In the Microsoft environment, for Outlook 2000, Microsoft has chosen to reduce the security settings. And in particular, at Microsoft, only specific attachment types, not the complete list of 38, but just a few attachment types are blocked, VBS being one of those. And VBS is the attachment type of LoveBug and the variations of the LoveBug virus that have been going around since May of this year. At Microsoft, users and departments can request additional security, so they can choose for Outlook 2000 to bump up the level of security if that's necessary for their environment. It is possible to set up, and Microsoft has done this, to set up different security settings for Outlook 2000 from Outlook 10. And Microsoft has chosen to do this. In the Outlook 10 product, Microsoft is deploying Beta 2 using the default Outlook security settings. And users and departments can request the security settings to be lowered or otherwise customized as needed. And the main reason that Outlook has chosen to deploy 2000 with lower security settings and 10 with higher security settings is that to avoid the need to retest a number of internal applications with the new object model guards for the Outlook 2000 product. And for Outlook 10, they were already doing that retesting, so they'd be able to retest it with security in place and then be able to roll out with confidence that they wouldn't be breaking applications that were part of the business need for certain departments. Our findings in rolling that out is that there's minimal server load. And in fact, the server load in order to read the security settings from the public folder is comparable to a single read-write of FreeBSY information, where Outlook reads or writes information, FreeBSY information to the server roughly once every 15 minutes. So that's just to give a sense of the scale. Outlook is already sending about that same amount of information to the server every 15 minutes, and this is a tiny increment on top of that. So specifically what we recommend to customers who are wondering what level of public folder support they'll need in order to support the security settings, as long as that company has public folders set up so that it can support their own FreeBSY needs in their organization, they'll be able to use customization. They don't need to have public folders fully deployed and be using public folders to store documents or to store group calendars and that kind of information. Now let's talk about some of the virus security features that are part of Exchange. The Exchange approach to virus security is to expose platform support tools to allow third parties and corporations to provide virus solutions, antivirus solutions that run on top of Exchange. Exchange does not support its own or does not provide its own built-in antivirus solutions. So the platform support that Exchange provides currently is in one of two broad categories. The first is store events, where some of the types of store events that Exchange supports are mapping notifications and transport sync events. And the second category of platform support is the virus scanning API. So the virus scanning API came out originally in Exchange 5.5 SP1 and was enhanced. That was the 1.0 version. There were some enhancements to it in Exchange 2000, and the Exchange team is working on the virus scanning API 2.0 version, which will be released. The time frame is not firmed down yet. The two possible time frames would be in the Exchange 2000 SP1 time frame. It might also be in the post-Exchange, the next release post SP1. So let's talk about these implementations. For store events, some of the advantages of store events is that store events allow scanning of messages on send, move, and copy, etc. Store events are a good tool to use for quick responses to new viruses. So specifically, once a new virus comes in and is identified, then a quick program can be written, and it would watch as any new message enters the store, and the program could be written to do any number of things, to strip the attachment from that message or whatever is appropriate given the type of virus. There are third-party products available that take advantage of store events to provide security. The other implementation is the virus scanning API. And with the virus scanning API, programs can be written to perform background scanning and rescanning of messages that are in the Exchange store. This is particularly good for purging known viruses from the store. So imagine in the case of the LoveBug virus, for the first certain number of hours in any corporation, for the first few hours, the virus was coming in, and because it wasn't identified, corporations weren't able to act quickly on it. So there were some copies of that virus, of the attachment, that would be already in the store. So virus scanning API would allow a custom product or a third-party product to be able to go through, identify any of those messages that had gotten in, and cleanse them. Typically, there's a slower, using the virus scanning API, it's not the best method for a quick response. And the main reason for that is that the virus scanning API supports one DLL, virus scanning DLL, to be running in the store process. And that virus scanning DLL might have signatures for a number of known viruses. And when a new virus comes in, a new signature would need to be created and plugged into that DLL in order to scan for the new virus type. But it takes some amount of time for a third party in order to identify the virus, create a new signature, and then distribute that to companies. So given that there are virus security measures in Outlook, and there's also support for virus security at the Exchange server level, let's talk about overall strategies and how Outlook virus security in Outlook and Exchange can be combined for the best mix of protection plus user experience. So which solution to use, Outlook or Exchange? Some advantages of Outlook are that it provides proactive prevention against new viruses. So because executable type viruses, say executable type attachments are blocked, any new virus that might come in that carries itself in the form of a VBS attachment won't be able to be opened by the user. The Outlook protection is also proactive. The object model guards is also a proactive protection against viruses that might get onto the user's desk in a number of other channels outside of email. So for example, viruses can get onto the user's desk by floppy disk, by access from a web page. Also, say for example, if a user has Hotmail and a virus might come in as an attachment to Hotmail and the user could open it that way. So for the object model guards in Outlook, protect against any of those viruses that might get executed outside of Outlook from coming in and making use of Outlook to gather information or self-propagate. Advantages of an exchange-based solution. A major advantage is that it's less intrusive to users. It doesn't block them from working in the way that they may have worked already. It's also client comprehensive, so Exchange stores can be accessed using a number of different clients. Outlook is one of those and the most popular, but OA is also widespread, and many organizations provide OA support to their email on Exchange. And Outlook Express can also be used when the access to Exchange is over a POP or an internet-based protocol. Another advantage of Exchange is that it supports purging bad attachments and messages, where in Outlook the attachments are still there, they're just blocked. So which solution to use? Well, a comprehensive solution can take advantage of both of the solutions. Specifically, it could use Outlook for ongoing protection and for quick response against executable type attachments. And then a server solution can be used for background scanning and for coverage across clients. Here's an implementation example that might use both. So an organization could deploy an Exchange server-based virus software and also deploy Outlook with the virus security features. And then using the administrator customization, the Outlook defaults could be set to a comfortable ongoing level as dictated by corporate security policy and also by business needs of the organization or of departments within the organization. So specifically, additional attachments, for example, could be, or attachment types could be allowed to be saved to disk rather than being blocked completely. And then under virus attack, the administrator can adjust the Outlook settings as desired from the public folder. And then once those settings are replicated across all the public folders in the organization, and after the amount of time that it takes to replicate, then all users will be protected from spreading the attachment because it will be blocked from them. Looking forward, I mentioned early on in the presentation that the virus protection in Outlook is near term and focused on having comprehensive support over all of the existing operating systems and across various server types. Looking forward, the approach that Microsoft is working on and Outlook is looking forward to integrating with is some virus security enhancements that are being built into the Whistler product, and Whistler is the next release of our Windows 2000 line of products. So some of the shortcomings of near-term solutions, both Outlook and Exchange solutions, are that not all executables are bad. Where Outlook currently blocks all executable type attachments. Some of those are bad, others of those are not. The UI guards that are provided for programmable access also degrade the user experience. Over time, we know that users learn to ignore prompts. Also, there's trustworthy code that needs to be able to call into the APIs and to provide rich new functionality for users. Scripting is a part of the long-term strategy for scalable administration, and certainly also it's part of Microsoft's long-term strategy for Microsoft.NET. So providing UI guards on top of the scripting can cripple the experience that we are looking toward in the future. Other shortcomings are that there are additional backdoors for viruses to execute, and I described a number of the ways that viruses can get onto users' systems in the previous slide. And there are plenty of legacy and new programmability models that are not guarded. So that's another shortcoming of the near-term solution. For Outlook, we've chosen to guard the most widespread programmability interfaces, but it's not a complete coverage. So some requirements of an effective long-term strategy. One is that there needs to be a comprehensive way to distinguish known good code from known bad code and also from unknown code. There also needs to be an efficient revocation scheme, a way to identify code that might have been marked as known good to indicate that there's something that has changed. So for example, I might be a virus writer and I've tagged on to someone's certificate and marked my virus as certified, and then it would be able to get into an organization and run. So there needs, and in today's world, there's not a good way for a specific instance that has a certificate on it to be revoked so that that application can't run. So that's something that needs to be addressed in a future strategy. And we also want, another of the long-term requirements is that we need a user-friendly sandboxing model, or a way, in particular, a way for applications that might be of the unknown type to be able to run in a scaled back way. The best way to think about this is in a web browser, how web browsers allow HTML to display, but script inside of the HTML might not be allowed to display, which does mean that the user experience with that page might be less, but it would allow the user at least to see what it is that they might get, and then they can choose on their own whether they want to trust that or not. So the long-term strategy, the Microsoft long-term strategy, is for the OS to provide a policy framework, the OS beginning with Whistler, to provide a policy framework for distinguishing between good, bad, and unknown code. And the OS is the common policy provider. It's the core, it's the one that executes applications if they are known good, and that prevents them from running if they're not good. Container applications such as Outlook or Word or even the OS shell are the policy enforcers, where a container application is an application that has a runtime, like a macro model, that executes some form of user-based code. So those applications, say for example Outlook, needs to communicate with the shell, with the operating system, to determine what security that code is that's going to run, and then together, and then the application will determine what it does when it knows the status of that code, whether it goes ahead and runs it, whether it runs it in a sandboxed way, or whether it doesn't run it at all. So time frame for all of the virus security measures across Microsoft. In the near term, application level virus protection is available. So we've talked a lot about the Outlook virus protection and the update that's on the website, and also what's built into Outlook 10. There is also protection in the Office applications using the macro security level. And then in other applications, for example IE, it includes the zones methodology, and also it includes support for Authenticode. So that's, in the near term, that's the series of Microsoft offerings for virus security. And then at the server level, especially in particular here, the Exchange server level, as we discussed earlier, there's support for store events and also support for the virus scanning API. In the longer term, the safer windows will be available. That's the known good, known bad, and policy support that's in Whistler. And then also in the longer term, Office applications, including Outlook, will leverage SAFER in subsequent releases of Office. This won't be something that occurs in the Office 10 product, but sometime post Office 10. Here are, in the slides, are some additional resources that can be used for more information. And then I've also included contact information on the 3 teams that are working in the Outlook Exchange and Whistler teams that are working on virus protection measures. So that concludes the session on Outlook virus security protection. And now I'm ready to take questions if there are questions from the field.
Doesn't appear there's any right now, so.
I think so we don't have any questions. Thank you very much for joining today. And please do use the contacts provided if you have additional questions later.